Greetings everyone, and welcome to my channel. In this video, we are going to talk about cost function in linear regression model. In linear regression, we use a cost function to measure how well our model fits the data. The goal of linear regression is to find the best fitting line that predicts the relationship between an input variable x and the output variable y. If you are interested to know more about linear regression, then you can watch it from the link that appears on the screen now. Now let's dive into the cost function. The cost function helps us evaluate how close our predictions are to the actual values. The cost function commonly used in linear regression is called the mean squared error, or MSE. It measures the average squared distance between the predicted values and the actual values. The equation for the cost function using the mean squared error for linear regression is J theta is the cost function, theta is the parameter of the linear regression model, M it represents the number of data points or examples in the dataset. Sigma denotes summation, indicating that the expression inside the sum should be summed up for each data point. H theta of xi, or hypothesis theta of xi, is the predicted value for the input example xi obtained by the linear regression model. Using the parameters theta, the x values are the independent variables. Yi is the actual value or target value for the input example yi. The y values are the dependent variables. Imagine we have several data points, each consisting of the number of hours studied x and the corresponding exam scores y. Our goal is to find the line that best fits this data, allowing us to predict the exam scores based on the number of hours studied. That's where linear regression comes into play. We want to find the optimal values for the parameter theta that define our line. This line, represented by h theta xi, predicts the exam score yi based on the number of hours studied xi. Our objective is to minimize the difference between these predicted values and the actual exam scores. To quantify this difference, we use the cost function j theta. The 1 over 2m term is a scaling factor to ensure our cost is reasonable. It divides the sum of squared differences by twice the number of data points m. The sigma symbol denotes a sum, where we iterate over all the data points. For each data point, we calculate the difference between the predicted value h theta xi and the actual value yi. We square this difference to ensure positive values and emphasize larger errors. Now let's dive into Python to implement the cost function. Firstly, we import our library. And then we implement our function. Then we set the x independent variable. This array represents the input variable, which is typically referred as the independent variable or features in a linear regression problem. In this case, the values in x represent the hours studied, and then we set the y, which is a target variable. The y array represents the target variable, which is typically referred as the dependent variable or the variable to be predicted in a linear regression problem. In this case, the values in y represent the exam scores. After that, we set the theta. For each pair of values in x and y, the linear regression model with the parameter theta, in this case equals 3, is used to predict the exam scores based on the hours studied. The cost function is then calculated to quantify the difference between the predicted values and the actual exam scores. The cost represents how well the linear regression model with the given parameter theta fits the linear examples, indicating the average squared difference between the predicted exam scores and the actual exam scores. Now let's print the cost value. And here we have the cost function equal 12. This indicates that the linear regression model with the parameter theta of 3 doesn't fit the training data very well. The cost represents the measure of how well the model's predictions match the actual target values. In this case, of a cost of 12 suggests that there is a considerable difference between the predicted values h theta and the actual target values y. A higher cost value indicates a larger error between the model's predictions and the ground truth. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.